Okay, so we're going to take a look at a couple of word problems. The first one here, we're going to look at question number 1. It talks about a pine cone falling from a tree branch. The tree branch is 20 feet above the ground, and then it gives us an equation, and it asks us to graph it. What's not happening in this problem is we are not graphing like horizontal distance and vertical distance, because if we've got a pine cone and, sorry, if we have a pine cone, it would fall straight down until it hits the ground. That's not really a parabola, right? But they're talking about h for height. Probably they should have put h of t. They just forgot the of t. And then the t being time and h being height. Looks like we're talking about feet. Most likely the time is talking about seconds. So when we graph this, our x-axis is our t, our time. And our y-axis, or our h of t-axis, is our height. And that's measured in feet. I will go to the calculator here in just a moment, but before I do that, what was the height when the time is 0, when time begins? 20. So when our time was 0, our height was 20. That's kind of our initial point. And then if we think about what's going to happen, the height decreases until it hits the ground. It's not going to be linear. Picks up speed as it goes, and then eventually it will hit the ground. When it hits the ground, what is the height? 0. So when it hits the ground, that is going to be an x-intercept. We don't know the y-coordinate yet. We'll use the calculator in just a little bit, but this path is part of a parabola. When I graph this, the calculator is going to show like a full parabola, but I'm only looking at part of it. And so what I would do is take the equation that they gave us, plug it into the calculator, and then I'm going to graph that. Hopefully you recall how to find the zeros on a graphing calculator. And I see then, we're using the graphing calculator, that we get 1.12, it's rounded, but that's going to be that x-intercept. 0.20 was the vertex. There would be an x-intercept back here, but do I care about this x-intercept? No, because that's when time is negative. That doesn't really make sense. You'll see that on the parabola in the graphing calculator, but I don't care about that. It doesn't pertain to the problem. So once we have our graph, we should be able to go and answer the questions now. Question B says, after how many seconds does the pine cone hit the ground? Well, that's when it hits the ground, that's when the height is 0. So we're looking for a 0 or an x-intercept. And so we see that was 1.12 seconds. I plugged the equation into the calculator. So I plugged in y equals negative 16 t squared plus 20. I graphed it on the calculator, and then I used the 0 function, like second trace, chose 0, did left bound, right bound, and then guessed to figure out what exactly that was. And then after that, part C, what are the domain and the range of the function? Oh, sorry, lost screen. Okay, what are the domain and the range of the function? Now, typically, when we look at domain of a quadratic, we would say it's all real numbers. But this is not just a typical quadratic or parabola, because we put it in the context of a real scenario where the x value, or the domain, is time. Can time be negative? No. The time started here at 0, and when did time end? The time ended when it hit the ground. So the time ranged from 0 to 1.12 seconds. So it was between those, and they used t instead of x. If you use x, that's fine. But to be consistent, I'm going to use t. That's what the problem gave us. It was between 0 and 1.12 seconds. That would be the domain of this situation. It was falling during that time period. The range, well, that would be where it started to where it finished. So this would be our range. What the highest it ever was 20, and the lowest it ever got, it stopped when it hit the ground at 0. So the height, which they called h, ranged from 0 to 20. So there would be our domain and range, which is different than what we would have had just for a parabola in general. But it's because of the real world situation that it changed. So I'm going to skip around kind of on this worksheet. We see a problem below this. I'm not going to do this problem, but I do want to point out that in this equation, they're talking about x being horizontal distance and y being height. It does not measure in time. So it actually is talking about the parabola formed horizontally and vertically. So, time would start at 0 with a height of 0. Maybe they hit the ground. The points that I would care about to answer the question would be the intercepts and the vertex. Those are probably the things you would want to find to then be able to answer your questions. I'm not going to go through this particular example, but it's not measuring time like the last problem. It's just vertical distance and horizontal distance. Let's take a look at this question. We'll see a lot of questions that are similar to this, where you have like a picture. In this case, they're saying a mirror, and they're putting a border or a frame around it. The mirror was 20 inches by 24 inches. We're putting a frame around it of uniform width. And so you see that as x. They're saying from here to there, that's the width of that frame, right, was x. And then on the same on the other side, it had to be the same thing, x. And then as we go vertically, x and x, it's uniform width. Now it's telling us we have 416 square inches of metal to use. That's not very realistic because you're probably not going to melt down the 416 square inches of metal and decide how to use it, but we'll go with it. We'll roll with it. We know the frame itself is 416 square inches. If we're talking square inches, it looks like we're talking about area. What would be the area of the mirror? Well, the mirror was a 20 by 24 inch mirror. So if you take length times width, 20 times 24, we see the mirror itself is 480 square inches. So what we're looking at here, we're trying to figure out what x is. We have a big rectangle, and we're talking area. So I would want to know length and width, or height, however you want to call it, of the entire rectangle. So what is this entire height? Well, we have the 24, and then we added x on the top and the bottom, so we added x twice. So that's 2 x's in addition to the 24 we had. What's our entire length? Well, we had 20, and then we added 2 x's, so 2x plus 20. Those are the dimensions of the entire rectangle. And if we're talking area, base times height, length times width, whatever you want to call it, we'll have to multiply the dimensions. And when we multiply the dimensions, it equals the area of the entire rectangle. Do we know what the area of the entire rectangle is? We do, because the mirror itself was 480 square inches, and the border or the frame was an additional 416. So when I combine 480 and 416, I get the entire area, which would be 896. So base times height is equal to 896. We have to now solve this. The left side is in factored form, but it's not set equal to 0. So I'm not going to leave it in that factored form. Instead, I have to multiply this out. So I'm going to distribute or FOIL that left side. So 2x times 2x is 4x squared. And then plus 40x plus 48x plus 480 equals 896. And now I want to simplify this and have it set equal to 0 at the same time. So I'll subtract 896 and combine my like terms. 4x squared plus 88x minus 416 is equal to 0. So now I have a quadratic equation that's set equal to 0. At this point in time in the chapter, we've learned 2 strategies to solve something like this. We could graph this and find the x-intercepts, or we could factor it. This one, I know it has a leading coefficient of 4, but I can factor a 4 out of each of the terms, so I think factoring seems like maybe the better option to me. You can go with either one, doesn't matter which option you choose, but I'm going to go with factoring. I'm going to factor 4 out of every term. So divide the 4x squared by 4, you're left with x squared. 88x divided by 4 is 22x. And negative 416 divided by 4 is negative 104. Equals 0. And then I'm going to try to factor that. I'm looking for 2 numbers that multiply to negative 104 that add to 22. Looks like a 26 and a 4. Positive 26. Minus 4, they add to 22. They multiply to negative 104. So now when you set each factor equal to 0 and solve, you see that x equals a negative 26 and x equals positive 4. Those are our answers, but think about them in the context of the problem, because most likely they don't both make sense. Does it make sense for x to be negative 26 inches when it's the border? No. So it solved the equation, but it doesn't make sense in the problem. So I could throw that out. Does 4 make sense? Yeah, it does. X could be 4. Now be careful, make sure you read the question so we answer the right question, because that may or may not be the final answer. It says write and solve an equation to find the border's width, and the border's width was x, so that is our answer. So we're talking about inches, so 4 inches would be our answer. I'm going to glance at the next question. I'm not going to solve the whole thing, but I want to make sure we know how to set this question up. Pizza shop is selling slices of pizza, 80 pieces at $2 a piece. We're talking about revenue. That's what they're talking about. It would have been 80 slices times $2. We take the number of slices times the amount of money, but they're saying they're going to increase the price by 25 cents at a time. Maybe we'll do more than one 25-cent increase, but for every 25-cent increase, we're going to sell 5 fewer slices. So here's how we're going to do this. We've got the price, we've got the number of slices, and when we multiply those together, that equals our revenue. So we know that the price, maybe I'll put the price first. The price started at $2, but I'm increasing, so I'm adding 25 cents at a time. So it could be multiple 25 cents increments. So I'm going to put 0.25x. But for every 25-cent increase, I know that means I'll sell fewer slices. We start with 80, but for every 25-cent increase, I subtract 5. So minus 5x will go to the 80. Now we have an equation. It is a quadratic equation. I will be able to graph that. You can graph that on the calculator. It'll be a parabola. It'll be a parabola that's opening downward. They're asking about the maximum. The value of x that maximizes r, and the maximum r value. So looks like all you have to do is figure out what this vertex is, and that'll answer parts B and C. All right, now you've been at least exposed initially to some word problems, so hopefully you can be successful as you go through the word problems on your review worksheet and then on your quiz and tests in the future.